Thank you for coming back today at our channel, The Physics Mindset, the only channel to give you a technical information in electrical installations, electronic repairs, and solar installations. Now today, since we finished up with the electrical charge and we are moving in series, slowly, because electrical, we don't rush. We are moving slowly, step by step. We finished the electric charge and we are going to see how we connect and how electric charge, the information we got from electric charge, how it connects with this topic today. The topic which is going to be about the electric current. Today we're going to see what is electric current and how does electric charge moves so that it produces an electric current. Master these terms in electrical. These terms you'll use them in your fields: electric charge, electric current, the voltage, the power, the resistance, okay, the capacitance. All you need to master these words to be a true technician. Since we have come across, now today we have come across our topic, which is electric current. And with a definition, I've brought this definition here. They say, is the rate at which electric charge flows through a conductor. The rate at which, if this is the conductor or our cable, this is a cable, okay? Now, the rate, electrons, once you apply voltage will push electrons which will pass through the cable or a conductor. Okay, now the rate at which this electric charge, the rate at which the electric charge will pass through a cable, that rate is what we refer to as electric current. That's why you will find some places where they put for you or indicate for you that there is high current, okay, or high voltage. Remember, where there is a voltage only is present to push the electric charge. And once the electric charge moves, we are having electric current. Okay? That is the principle or the experiment you need to have. Once there is a voltage, just know there is current, because a voltage is just a force, okay, which pushes electric charge to flow through a conductor. Which conductor? We have said, let's say a cable, our copper cable. Once electric charge pass through this cable, that rate at which current flows is the electric current. Technical engineers, technicians, you need to have this information, because electric current, without knowing electric current, these are one of the fundamentals. Without knowing these fundamentals or these concepts, it will be hard for you to master electrical engineering. So you need to have these fundamentals. And before we are going to start the generation of this electricity, you need to have these terms with you: electric charge, electric current, resistance, capacitance, power, okay, current, and this is how we have come up with the definition of electric current, which says that it is the rate at which electric charge flows through a conductor. Okay? Now, let me rub off this. Let me give you some concept. Do you know that a battery is not the one which gives us current? A battery is not the one which gives us current, but a battery only provides for us voltage. This is our battery. This is our battery. Oh, this is our battery. Okay? This is our battery. And a battery only, let us have a circuit. Okay, This is a switch. This is a bulb. This is a battery. And this is current. This is battery, volt 1. Source of power is the battery. Okay, now a battery only provides us with the voltage. Okay, but it doesn't provide us with current. This voltage, the use of the voltage is to push the electrons, the small particles, the atoms inside the cable to move. If a cable is conducting, meaning it has electrons and protons, always number of electrons are the same as number of protons. Though protons are in nucleus, they don't move. They're nucleus in one place with neutrons. Okay, only electrons are the one which move. Now, once you apply the voltage to the electrons inside the cable, electron will move. Voltage will push. Voltage is the force which pushes electron or electric charge to pass through the cable. And once the electric charge passes through the cable, the rate at which this electric charge is passing through the cable is what we refer to as electric current. And this is a switch there to control. Now here, if it is on, meaning power or electric charge will reach at the bulb and it will be used by the bulb. A bulb will change this electric charge or electrical into light energy or into heat energy. Okay, now in the return here, positive, here it will be a positive. Remember negative. Only currents, only electrons. Electrons are the one which move from the battery to positive charge, from negative charge to positive charge. If this is the battery, positive, negative, current, electric current, electric charge or electrons. Remember, electric charge have two types of charges: positive charge and a negative charge. A positive charge and a negative charge. But electrons move from a negative to positive. As I told you, electrons move from one place to another. That is electricity. That is the definition of electricity, whereby it is the movement of electric current or electrons from one place to another, or from one cable to another cable. Let us say you have done a junction. This is your cable, this is the junction, this is another cable which goes to the switch, okay, and goes to the light. Now this junction, current will pass through from one cable to another cable, okay. That is what we say, from one place to another. Now, electrons, once we talk about current, we talk about electrons which move from negative. But listen this, engineers use the principle of conventional current. Conventional current is a type of current which move from positive to negative, from positive to negative, okay. And the engineers, mostly electronic engineers, they use this principle to analyze circuits in, let's say, in your screens, in your TVs, televisions, in your radios, the circuits inside, which circuits are made of electronic components, the resistors, transistors, capacitors, okay, the inductors. Now, inside your TV, we use the principle of conventional current. Mostly the technician doing the repair, they use this conventional current to to do their circuit analysis. When you're repairing a TV, a phone, an electronic gadget, you will use this principle of conventional current, whereby positive current moves from positive to negative. But in actual sense, electrons move from a negative terminal to the positive terminal on the battery. But some people will take all our knowledge to use the conventional current principle, whereby we think that on the battery, positive terminal is where electrons move to negative. No. Electrons, which is E, on the atomic structure, we said on the atomic structure, let me write here, on the atomic structure we said there is a nucleus which is holding a positive, a proton and a neutron, and the outer shell there is a valency, E, electrons on the outer shells carrying a negative charge. And in the nucleus we have proton which carrying a positive charge and a neutron which have no charge, it is neutral. But people tend to think that on the battery power moves from the positive. No, it moves from the negative, static electricity. So let's come back to our diagram. Current, since the rate at which electric charge pass through this cable to the bulb to consume it, okay, bulb will consume this electric charge into light and heat energy. Okay, now, and the battery, the pressure, which is the voltage, will push, the current. Voltage will push the current. Okay, that's why we have a principle in Ohm's law, whereby a voltage is equals to IR, because voltage, it pushes this current one, and in the moment of pushing, there is resistance in the cable. Every material has some resistance. Okay, a copper, if it is a copper wire, it has some value, resistance value inside the copper material. And the moment the voltage is pushing the current, there is also resistance, because current and resistance have combined together. That's why when we are finding the voltage, we shall multiply current times resistance. Okay, and this is the principle. Hope we are together according to our illustration. Okay, now these electric currents, they are so much interesting, because from the smallest electric, let's say a smallest LED light, to big factories, large factories using electrical, they wouldn't have operate in existence, but only with the help of electric current flowing through the conductor. Without electric current flowing through a conductor, without the rate of charge flowing through a conductor, there wouldn't have anything, lighting, TVs, factories working, no. Everything would have shut down. But because of the presence of electric current, or the rate at which electric charge flows through a conductor, we shall have our bulb working. And once our bulb works, meaning we can also connect here a motor, and the motor can work to produce, motor changes electrical into mechanical to produce the products we are seeing from the factories, meaning the factories will work because of the presence of electric current. That's why I say, without having these principles as you, the technician, an engineer, okay, electrician, without these concepts, these fundamentals in electrical, we shall not having even these shirts we are putting on, because they are from the factory, because of the principle of electric current, which we need to know as the fundamental where electricity started. We need to have these mentalities with us, that without the rate at which electric charge flows in a conductor, we will not have anything. Hope we are together. And this is an electric current. Now, I was here on the conventional current is the current which flows from positive to negative. Okay? But in actual sense, electrons move from a negative to positive. Only engineers in electronics, they use this principle of conventional current to do their work in electronic board, right? Repairing your phones, and we are going to see all these things, and we are going to use these principles, and I will show you how we use this conventional current principle to repair in electronics. Wait for those videos, okay? Just keep on pace with us, subscribe on the channel, and don't miss any tutorial which is coming, because our aim is to give you the knowledge so that you can use them in your day-to-day lifestyle to solve people's problems. Now, without an electrician knowing the electric current, it will be hard for him to understand resistance. And you have seen how we have come up with the sum of the Ohm's law, which says that voltage is equals to current times resistance. Because the voltage is just a force which pushes current, but in an interval of pushing, there is an resistance. Every material has resistance. Even you, when you're moving on the road, there is that resistance of the air in the atmosphere. That's why people use a lot of force when they are running. Okay? So that they pass through the resistance of the air. Inside the air, the atmosphere, there are resistance. There are air particles, water, dust, all those things, though we can't see them with our naked eyes. But we can think that, yeah, when I'm moving, I'm using the hands to penetrate this resistance. And this is the principle. Okay? Okay, now, after knowing the principle of electric current, okay? Now, let us see something which is so much crucial in this electric current. People ask that, how can I calculate something on electric current? Because we have, if you get a question which is having electric charge and it has some time in it, the best formula which I can give you when you're calculating electric charge, remember the formula we used when you're calculating electric charge. Now this is calculating electric current. Calculating electric charge, we said electric charge, this represents a charge which is equals to, current times time. That is calculating for electric charge. Any question which has electric charge or coulombs, because charge is measured in coulombs. Now, if you are calculating electric current, whereby current will be equals to charge over time, whereby I represent current, Q represent electric charge, and T represent time. Okay, now we use this formula to calculate for current, for electric current. In any question which has, let us say, let me use Let me use a red color. Let us say a question. Let us say a question. If 20 column C, which is representing electric charge, because it is measured, its SI unit, the international standard unit, is in column. If 20 column of electric charge flows for 5 seconds in a circuit or in a cable. If 20 column, let me rub off this so that we get some space. If 20 column of electric charge flows for 5 seconds, this is the cable. If 20 column, 20 electric charge flows in a cable for 5 seconds, 5 seconds, that is the time. Now, if they say calculate for current, we are looking for current, meaning current equals charge over time, and our charge, electric charge, which is 20 divided by 5, we shall get, this is current, this is electric current, and we shall have our 4 amps. Never forget these SI units, the international standard. It is international standard unit. Without only, if you put only 4, we don't know 4. Current, someone may say, this is inverter because of I. But once you put an SI unit on your answer, please, if you're a student, never forget the SI units. And we need to have a video on SI units so that you master the things and you be with them. 4 amps, meaning current which will be passing through in 5 seconds, carrying a 20 column, will be 4 amperes. And amperes is the SI unit of current. Okay? Because this electric charge, an electric charge is the movement, electrons. Let us say also this. Let's also pass the thing to you. An electron, one electron like this, it carries much big quantity of electric charge. Let me say the standard unit of electric charge is the ampere, and electric current is the ampere. But an electric charge, the standard unit of electric charge is the coulomb. For electric current is the ampere. These things look a bit similar, but they are not the same. Okay? One electron like this, if you have, let us go back small on our atom. This is electron with a negative charge, electron with a negative charge. These are protons inside here. Okay? Now, one electron like this, it has much quantity of electric charge. And this is one electron has 1.602 times 10 power 19 coulomb. These are charge in only one electron in an atom. But remember, a material or a copper or our cable is made up of very many atoms. But only On an atom, there is electrons, and the number of electrons are equals to the number of protons. Meaning, if you're having in electron, if you're having, it is a negative 1.602 times 10 power 19 in coulombs. This is electric charge in one coulomb, one electron. It means also, remember, a number of electrons are the same as the number of protons. Meaning, even in protons, in positive, which is carrying a positive charge, will have the same 1.602 times 10 power coulomb. And this is the standard figure in electronics. When you're calculating electronics, calculating for electrons in an atom, we use this standard figure. Okay? Now, let us have something small, which I want to show you. Types of electric current. Today we are dealing with electric current. Let us have some types of electric current. Let me rub off this. Okay, now, let us see what are the types of electric current. Types of electric current. Okay. Types of electric current. Remember, we saw when we were talking about electricity, types of electricity, we saw that we have two types of electricity. One was static electricity. Two was the current electricity. Now, on the current electricity, this is what we are talking about. Electric current. That is the current electricity. Whereby, under the current electricity, we have two types also. One, we have a DC current, which is the direct current, and an AC, which is alternating current. Okay? Now, under electric current, we have two types, and a direct current, which is called a DC current. Which DC current? This is the current which we use in our electronic gadgets, like the phones use the battery to power them. That is a DC. Some DC power supplies to power on our gadgets. Okay. Laptops, TVs, okay, they use DC power, okay, and this is the direct current. And this direct current is also produced by solar panels, okay. Solar panel produce DC, the batteries, power banks, all they produce DC power source. This is it is under the type of currents. And it moves only, I'm talking about DC. It moves in one direction. A DC current moves in one direction. It moves in one direction. Okay? This is one of the characteristics of a direct current type of electric current. Moves in one direction. If it is a positive, negative, in one direction. Okay? It's produced by solar panels. Now, for AC, for alternative current, one of its characteristics is they change direction. Alternative current change direction. They go and come back. But A DC goes direct, but AC changes direction. Okay, one of the characteristics. This is why it changes direction, and this is what we use at our homes, in the factories, offices. Okay, because it has high efficiency to manufacture, to produce some strong electrical power. It is why it is through an AC, alternative current. It is produced by the generators. Produced by generators at the power stations. Power stations, I mean the dams. Okay, we shall see when we're about to reach the generation of electricity, and we shall see how AC is produced using the generators at the power stations. Okay, and this is the type of electricity we use at our homes. Okay, now electric current. Do you know that it also has an instrument which measures it? Technically, electric current, you're talking about amperes, and the instrument which is used to measure electric current in a circuit is called an ammeter. An ammeter is the instrument which is used to measure electric current in the circuit, and it is connected in series. When you're measuring current, you connect this ammeter. Let us say if this is our battery, okay, we want to measure current inside, we put in series. Now this is the ammeter, this is the switch, this is our bulb. The circuit is complete. Now this ammeter, this is the switch, this is the bulb, this is ammeter. The ammeter is connected in series in the circuit, series with the circuit diagram, and it will show you the current which is flowing. The current which is flowing in the circuit. That is an ammeter, is connected in series. Okay? And without connecting this, remember, even this ammeter has low internal resistance inside it. The ammeter has low internal resistance. Remember, when power is moving, just no resistance. We shall have resistance. That's why I told you this formula. Voltage, once the voltage is applied to push current, it is fighting to push the current through a cable, which cable is having some resistance in it. You can't escape resistance. Anywhere, resistance is always there. Whenever you are seeing something, even water, when water is pushing, when the pressure is pushing water, there is a resistance, either in the valley slope, either it is a bit of hilly. Always resistance will be there, and you'll need a pressure whereby water needs that pressure. In electrical, we need pressure, which is the voltage from the battery, which voltage which you refer to as the potential difference. Okay, the voltage in the battery, we put PD, the potential difference. And if you have the knowledge about electric current, please note that this knowledge, you're going to use it in your day-to-day life. You need this thing in electric currents so that you solve a lot of problems. The formulas, unless when the formula, the formula which I have given you, which is charge over time, but If they ask you, this is current, which is equals to charge over time. But if they ask you a question which is having power and it's having some resistance, there is a formula also for power, electrical power, which is IV. You can use this formula because there is voltage and there is power. It depends on which question. In ohms, there is another formula where you can find current, which is current equals voltage over resistance. It depends on which formula they have given you. And I'll give you the tricks. If you're a student, master the formulas. But once you master the formula, you must know how you can drive the formula using a circuit diagram. That if voltage is applied, current, electric charge is pushed. And that electric charge, once it is pushed, that is electric current. And once the electric current is moving, there is a resistance which is resisting it. And that's why we come up with this formula. This formula. If the charge is moving, time always moves. Time moves. Now, that's why once a charge moves per second in a circuit, we calculate for current. If you have this formula from the beginning, as we started with the electric current, I know you have got some information. Write down something, do some examples, think so that you don't forget, and use this information to solve people's problems. People will call you to repair electrical, electronics, or to repair some problems in solar systems. You will need this information. Once you use your head, you use the meter and it has failed, it needs you to go back on the formulas. And once you apply the formulas, you can find the answer. Whereby someone can call you on solar systems or in electrical. Let's say on a solar system, you don't know, you ask, how many solar panel wattage did you install? You see how you're going to invest in a formula. You'll have the formulas with you. And once you have the formula with you, once you know the panel, you know the battery value, go and check if it is 71 ampere hour, 100 ampere hour. If the panel is 100 watts, what is the wattage of the charge controller? You'll need to know the number. Always in physics, we deal with the formulas to solve a lot of concepts or a lot of problems. Thank you for watching. Let me see you in the next video, which is going to be all about resistance. Now we have seen that there is resistance in the flow when the voltage is pushing electric charge to the rate at which electric charge moves. It is pushed by the voltage. And electric current is the rate at which electric charge is moved. But what pushes that electric charge? It is the voltage. And in the interval of moving, there is resistance. There is this resistance. Resistance. And this is our next video. We are going to talk about what is this resistance. I want you to know these terms in electrical. Any electrician, any engineer knows what it calls resistance. Once he hears about there is some resistance, he knows what to do. And this is why I want to give it to you. If you talk about there is some current, he knows what current is. Electric current. There is some charges. He knows what it means. Either there is a positive or a negative charge. There is some power. Okay? I want you to be this technician which the world will need ever and forever. Thank you for watching. See you in the next video.